Today we're going to be talking about inverse derivatives. So we're going to be looking at inverse derivatives in two different ways. We're going to be finding inverse derivatives of just all functions in general using what we call the inverse derivative formula. And then we're going to be finding specifically the derivatives of inverse trig functions. But first, let's kind of talk about what we know, what we don't know about inverses. So here on the coordinate plane, we're going to graph f of x is equal to x squared. And then we're going to mark the point 2, 4 really clearly. Okay, so f of x equals x squared, that's just a parabola. So boom, boom, boom. Remember, y'all, as always, it is not a big deal if you don't know how to graph these. Okay, you can always use Desmos or your TI-84 or something like that. And then I want to mark that point 2, 4 really clearly. So up here at the top, a couple of questions. So is your graph one-to-one? So what does it mean for a graph to be one-to-one? It means that every x value has a unique y value. That means no y values are repeated. Well, looking at our graph, it's not one-to-one. All the y values on the left side are repeated on the right side. Hey, so will your graph have an inverse that is also a function? Well, this is a consequence of the graph not being one-to-one. So if you remember talking about inverses in pre-cal at all, if a graph isn't one-to-one, if it fails the vertical line test, remember that's if I draw a vertical line, like so. So if it fails the vertical line test, if it touches a vertical line more than once, then it fails the vertical line test, it's not one-to-one, which means its inverse will not be a function. Okay. So essentially this just means that if we were to try and take our inverse, which remember an inverse is that reflection across the y equals x lines, that switching of the points. If we were to reflect that across, our inverse would fail the horizontal line test. So that's what it means by the inverse not being a function. Okay, so we would say no. Now, regardless, if I wanted to find the inverse, I could still find the inverse. Okay, so the inverse function, if you remember how to find inverses, so our original function is y equals x squared. So to find an inverse, we switch x and y. So x is equal to y squared, and then I'm going to solve for y by getting y is equal to the positive or negative square root of x. So I'll just move that squared over to the other side by taking a square root. Okay. So that is my inverse function, my square root function. Okay. Now, the last thing I'm going to do is find f prime of 2. So I have f of x. So let's find the derivative. So f prime of x is equal to 2x. So f prime of 2 would be equal to 4. And I'm going to use this information to find a tangent line equation at the point 2, 4. So 2 is my x value, 4 is my y value, and then 4 is also my slope. So y minus 4 is equal to 4x minus 2. Okay. Everyone good with me so far? Okay. So we're going to keep going. So on number 2, we're now going to flip over and we're going to talk about our inverse. So we're going to graph g of x is equal to square root of x in a different color. And we're going to mark the point 4, 2 clearly. Okay, so I'm going to do here. So square root curve would go right here through the origin. And then square root of 1 is 1. Square root of 4 is 2. Okay, and I want to note the point 4, 2. Okay, is this a function? So yes, the square root of x is a function. Okay, so you might be saying, but Mr. Arbone, this is the inverse, and we just said the inverse is not going to be a function. Well, remember, we didn't graph our entire inverse. Our entire inverse would be positive and negative square root of x. So if I added in the negative square root of x, boom, 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 boom. Okay, now that curve would fail the horizontal line test, which would mean it's not a function. Okay, so that's why we only graph the positive square root of x so that we can actually compare them and we can use it as a function. Okay, so still not a function. for the full inverse, but what we did graph, just the square root of x is a function. Okay, so now we want to find g prime of 4. So g prime of 4, so once again, I'm going to find the derivative. So my function is g of x, so g prime of x is equal to 1/2 power comes down, x to the negative 1/2. And because I'm going to be plugging in, I'm going to go and simplify this to be 1/2 square roots of x. So g prime of 4 would be equal to 1/2 times the square root of 4, which is equal to 1/2 times 2, which is just 1/4. Okay, what is the equation of the tangent line at the point 4, 2? So same thing, I have the point, I have my slope, so I'm just writing my equation of the tangent line from there. Y minus 2 is equal to 1/4 x minus 4. And last but not least, we want to compare the slopes of f of 2 and g of 4. Okay, so let's talk about this just a little bit. So my slope of my original function, my f of x, was positive 4. My slope of g of x was positive 1/4. Okay, so what is the relationship between 4 and 1/4? Well, the relationship that you should notice between them is that they are the reciprocals of each other. Okay, now how this pertains to us in terms of calculus and in terms of slopes is sometimes I might want to find the derivative of the inverse function, but unlike these two functions, x squared and square root of x, where it's fairly easy to find that inverse function, it is not fairly easy to find the inverse function of, say, x squared plus 3 over x to the 4th minus 7, or the natural log of sine of 2x, something like that, where it's a much more complicated function to try and solve out and get y by itself after switching that x and y. So we can't always just switch x and y and find the inverse function. Sometimes we have to kind of use what we know about the original function and its inverses derivatives, and that they are reciprocals of each other, to calculate the derivative of the inverse function. So this brings us to our steps of finding the derivative of an inverse function at a point. So this is in general. So this is for all inverse functions. It's always true. What we just proved here with square root of x and x squared is that their slopes are reciprocals of each other. So the same idea holds true here. Okay, our formula says that the inverse function's derivative at a, or g prime of a, is equal to 1/, the other function's derivative at b. So reciprocals of each other, and we plug in the opposite x and y points. So this is a little bit weird, but I'm going to go through these step by step. Okay, so let's look at an example. So number 3, let f be a function, f of x is equal to square root of x minus 4. If g of x is equal to f to the negative 1 of x, so that's saying if g of x is the inverse of f, and g of 1 is equal to 5, what is g prime of 1? So I'm going to solve this without actually finding what g of x is. I'm just going to be using f of x. So my first step here is to define points. It's very important with our inverse functions that we define our points so we don't get them mixed up. So on g, we have the point 1, 5. So that same point on f is 5, 1. Okay, so inverse function, so it's just switching x and y. So we just switch the point for f. Okay. Second step is just writing out the formula and placing in our values for a and b. So it's really just understanding, okay, what are we trying to find? So I actually know what I'm looking for as my end result. So I'm trying to find g prime of the a value, or in this case, I want to find g prime of 1. So if I want to find g prime of 1, that would be equal to 1/f prime of the b value, or 1/f prime of 5. It's always just the opposite value. So g prime of 1 is equal to 1/f prime of 5. So now I know what I'm looking for. I need to find the derivative. I need to find the derivative at 5. and then I'm just going to take the reciprocal of whatever that value is, because it's just going to be 1 over the derivative's value at 5. So step 3, let's find that derivative. So f prime of x would be equal to, that is a 1/2 power, which would come out. It's a chain rule, so x minus 4 stays the same on the inside. Negative 1/2 power, 1/2 minus 1 is negative 1/2. And then I multiply it by the derivative of the inside. Derivative of x minus 4 would just be 1. Okay? And because I'm going to be plugging in, because I want to find f prime of 5, I'm going to go ahead and simplify this so that I can actually plug in. So f prime of x is equal to 1/2 is going to stay on the bottom. X minus 4 to negative 1/2, that's going to go down to the bottom. And it's just times 1, so I can leave the rest of it like it is. Okay. Now step 4, I'm going to actually plug in my value for f prime. So I want to find f prime of 5 is equal to 1 over 2 times the square root of 5 minus 4, which is equal to 1 over 2 times the square root of 1, which is just 1/2. And then last but not least, step 5, I'm plugging it back into the formula. So I want to find 1 over f prime of 5. So 1 over 1/2 would just be equal to 2. I'm just taking that reciprocal. Okay. Now, some of you at this point might be thinking, like, Mr. Arbone, these are a lot of steps. Can I just skip right to the end? You absolutely can skip right to the end. I don't need to see all this work every time. This is just to help kind of keep your work straight as you get used to using this inverse derivative formula. Okay, you don't have to use it every time. It's not like a use it or else you get a 0, something like that. It's not like this is our proving or we're justifying that the inverse derivative is here. I'm just finding the derivative of the inverse. Okay, so you don't have to show all this background work. I mean, I do expect to see, like, you found the derivative, you plugged it in, you took the reciprocal of it. I want to see those 3 things, but like, you don't have to write the formula every time. You don't have to define the points every time, although I think it's really helpful. You really just need to show derivative, plugging in to get the value of the derivative, and then taking the reciprocal for your final answer. Okay, one last example. So number 4, let g be a function. G of x is equal to x cubed plus 2x minus 1. If f of x is the inverse of g, and f of 2 is equal to 1, what is f prime of 2? Okay. So this one, they kind of switched f and g on us, but this whole thing still holds true. Okay, so step 1, stating our points. So our point on f is 2, 1, which means our point on g is 1, 2. Okay, 2, we're stating what we want to find. So f prime of 2 is equal to 1 over g prime of 1 by our inverse derivative formula. Step 3, I want to actually find g prime. So, getting ahead of myself. So g prime of x is equal to 3x squared plus 2. Step 4, I'm going to plug in 1 because that's what I'm looking for, g prime of 1. So g prime of 1 is equal to 3 times 1 squared plus 2, which is equal to 5. And last but not least, step 5, I'm going to plug it into that formula. So 1 over 5, well, that's just equal to 1/5. We're done. Hey, so it can be relatively straightforward. It's all really depend on 2 things. How difficult is the derivative you have to take? And then 2, making sure you don't get your points mixed up. All right, I will tell you every single time, like if I would have accidentally plugged in 2 here instead of 1, if this is a multiple choice answer, which these will really exclusively show up as multiple choice just about, you will bet you that the answer, if we would have plugged in 2 instead, will be there. The answer, if we don't take the reciprocal, would also be there. So 5 would be an answer choice, 1/5 would be an answer choice, and if we plugged in 2, 2 squared would be 4 times 3 is 12 plus 2. So 14 and 1/14 will probably also be there. So they're going to try and distract you by, okay, did you plug in the wrong number or did you forget to take the reciprocal? So you really need to know this formula to get these kind of questions right. Okay, but that concludes inverse derivatives just using the formula. The second notes is going to be inverse derivatives, but with trig.